And we will solve this today's LeetCode problem. So the question is an easy one, but let's see what the question is. It is a minimum number of moves to sit everyone. So let's understand the question. So there are n seats and n students in a room. You are given an array seats of length n, where seats I is the position of ith seat. You are also given the array students of length n, where students j is the position of the jth student. So we have given a seat, right? And the seat side represents the position of the ith seat, and the student array is given where the particular student jth is the position where the student is currently placed, right? It is the position where the students is currently placed, and here are the seats of array where the seats are present, right? So you may perform the following any number of times. Increase or decrease the position of the ith student by one, that is moving this ith student from position x to x plus one and x minus one. Return the minimum number of moves required to move each student to a seat such that no students are in the same seat. So here is the thing that we need to basically move this student position either by 1 or minus 1 to accommodate with these seats which are given, right? So it is confirmed that both the number length of the arrays are same, basically seats and students, and just we need to place each student to each place by moving them a minimum number of times, right? And here it is also written that there may be multiple seats or student in the same position at the beginning, right? So we need to place it as each student to each different seat, right? So the question is clear that we need to move the students to each different seat, right? Which is given in the seat side, right? By moving them either in either by uh, x minus 1 or x plus 1. X is the position of this current student, right? And we need to find the minimum number of moves. We need to find the minimum number of moves, right? So if we see example here, seats 315 and 274. So here you see this 315, this is the 2. So for these two, the nearest number, so for finding the minimum number of moves, the first thing is clear. For finding the minimum number of moves, one thing is clear for finding the minimum number of moves, mean number of moves, one thing is clear that we need to move in in nearest seat position, nearest position of seat, right? That's the for sure. Then I can move in nearest part, that for sure, right? So if you see here, this is the student position is 2. So what is the nearest position? This 2, either it can go to 1 or either it can go to 3, right? So I can choose for 2, 1 and 3 both. But if I choose 3 for that, if I choose 3 for that, then the position for 4 will, what will be the position for 4? Either it is 4 will be 5 or either it can be 1, right? And for this 5, if I choose 5, then for this 7, the position left only with 1. So that will be the 6 difference, right? So if I choose 2 to 3, that will be 2 to 3, 2 to 3. It gives us the answer 1, definitely sure. If I then I move to 4, if I choose 4 to 1, if I choose 4 to 1, it will gives us 3. And when I go to 7 to 5, which is left, then I go to 2. So answer is 1 plus 2, this is 6, right? But instead of going from 2 to 3, if I instead of going to 2 to 3, if I move to 2 to 1, so it will generate 1. Then from 4 to 3, it will also give 1. And from 7 to 5, it will give 2, which answer is 4. Right? So this is the minimum times which we need to, right? So one thing is clear that we need to move in lowest direction. We need to move in nearest position seat, but where position seat? So here, if you observe one thing, if you observe something, if you observe something, that the of a student order of student and seat is doesn't matter to us, doesn't matter to us, right? Observe, right? That the order of student and seat does not matter to us, because any student can be placed at any position. But for finding the minimum number of moves, we need to find the nearest position seat, right? And the students and the seat numbers are fixed. So the thing is, whenever the order is not maintained, you can think of you can think of sorting. You can think of sorting, because the order is not maintained. Orders doesn't matter to us, and we need to find the minimum number of moves. So each student should be placed at nearest position, right? Each student should be placed at nearest position. So for finding that, can we think of sorting? Just think of sorting. So if I think of sorting, what I will do, I will sort both of them. If I sort both of them, 1 3 5 and 2 4 7, now if you see, we got something that at the specific position, at each specific position, if you take the difference, it will be generate the minimum number of moves, always. Why? Because this is working, because it because if you take with 2 with 5, then you need to take this 4 with 1 or 3, and 7 with 3 or 1, which is large difference from this 5. If you take this 5 or 7, or 7 with 3, which is the larger? 7 3 is the larger, right? So for taking the nearest, we just need to sort both of them, because the sorting we gives you an idea that I'm sure about that the current state is the minimum number of moves I will get, rather than the moving in previous, or uh, rather than moving in after and previous state, right? So this is a student, and this is seat, right? This is student and this is seat, right? So I'm sure after sorting that this difference between both of them will give me definitely an optimal answer, right? And that's the whole question enough, and the solution is over. That's just sort the elements and take the difference, just think. So how we will take the difference? Just take the difference between both of them, because either we can move in -1 or +1. So you need to take the absolute difference, because either 2 can be moved to 1, or 4 can be moved to 3. So in this, it is just decreasing, but it can be possible that it will becomes 4 8 and 9, right? It can be possible that it becomes 4 8, and it can also become 4 6 and 4 6 and 7, right? It can also be occurs, right? The seeds are 4 6 and 7. So in that case, 2 should increase to 4, 4 needs to increase to 6, and 7 needs not to go anywhere, because this 7 and 7 is uh, at the same position, right? So we just need to take the difference between both of the students and the seats position, and add in our answer, and that's will be the our answer, right? So we just need to short it. So yeah, this is the easy problem, right? Definitely, you have solved it. I'm very much sure about that. But just need to implement, or you just need to what do? You will just short this seats. You will just short this seat from whole sheet, right? And I will not implement that. You can implement. No. This is the very basic, very basic, and this is the student begin, and this is the student begin, and you just need it to iterate from. You just need to iterate and store in the answer, like that. This is the just an implementation, just an implementation, and just you need to return the answer simply, right? This is the okay. Just let's uh, run this, right? And there is the seeds dot size, right? And just that's the whole answer in the 2 lines, right? I hope there is no compilation error. There is a compilation error. Seeds, okay. Seeds, right? Students. Answer is not defined. Arey, now this should work. Now this should work. Yeah, submitted. So, what are the time and the space complexity for this problem? Right. What are the time and the space complexity for this problem? So, time will be O of n log n plus O of again O n log n, because both of the seats and the student size is same. So, you can take this as O of n log n, right? And what are the space complexity? Space complexity would be O of 1 only, because we haven't taken any extra spaces, right? These are the time and the space complexity. Now, main thing, can we do something else less than this? Let's analyze one thing. Now, this approach is can be used in many of the problems, in many of the medium problems, right? So this is an easy, but still, you need to know this, the counting shot. Right? What this counting shot do? So if you see here, the length of the constants are only 100, right? So it means, and the seats and the students j can be go to 100. It means we can store the available seats, right? So store all the we can store the maximum seats, right? Because maximum seat can be possible is 100, right? So we can store maximum seats in our array, right? Definitely we can store. Can we do something like can we do use this for our algorithms? So one thing you see here, suppose we take this example 41591326, right? We take this example, right? Now if you see here at this position seats, the maximum position is 9, right? We can move to maximum position 9, right? So 1 2 3 4 5 6 7 8 9, right? We will move in this fashion. Now if you see one thing, if you see, the 4159 is the position where can students be available, right? Where this can students be available. So if I simply assign one thing here, that this seats assigned one part, where are the seats available, I will just mark it as 1, and where the students are placed, I will mark it as -1. Why I'm doing this? Just be with me. So this is at 1, so I will mark this as 1. This is 4, so I will mark this as 4. This is 5, I will mark this as 1. Again this is 9, I will mark this as 1, right? I have marked this one. Now what does 1 represent? 1 represent that I got that these seats are available. These seats are available. Are available, right? These seats are available, right? Okay. Now these seats are available, and students must be placed at these seats, right? Now the students' position. Students are already placed at some place. So what are the position? I will mark it as -1. Why I'm doing this? Let's be with me. 1326. So you see, at the seats position we have already one, and this is 1. It means we don't need to move this. So what I will do, and I was marking this -1, so 1 minus 1 would be 0, so it becomes 0, right? And 3, at 3 position it becomes -1, so I will mark it as -1. I will mark it as -1, right? Okay. Now if you see here, this one part, this two part, 2 is also marked as 1, so let's mark this as -1, right? I will mark this as -1. Now this 6 also is -1, so I will mark this as -1. Now why I am doing this, let's understand, right? And the rest position uh, which are not available here, marked as 0, 0, 0, and this is 1. Okay, we got this something like this. We got something like this. So why I'm doing this? See, -1 represent the position of students. Sure, right? What does 0 represent? 0 is a place where no students are placed, and no seat are there. No there, and there is also no seat. There is also no seat. No seat. Right. So now if you see here one thing, that if I want to move, so this position 2, at this position 2, this is the one at 0. It means we don't need to move this simply. We don't need to do this, because this position is where the no students are placed, and there is also no seat. Or this one and this one is the similar. It means we don't need to change this. We don't need to change this one and one. That's why it represents 0. Or the seat and student position is same. Position is same. That's the representation of this 0, right? Now one thing, when this 2 and 3 is position, when this 2 and 3 is position, don't you think, yeah, when this 2 and 3 is seats position, and this 4 is at 1, it means what does it mean? That this 2 should be placed at some place. Let's analyze it by taking some examples, right? So let's see here 0. I'm taking I'm taking random numbers. Let's suppose this is 2, 6. Okay, let's take is that 2, 3, 4, 5, 6, 7, and mark it as -1, 0, then 1, then again 0, 0, or -1, or 0. Okay. Okay. So here one thing is, I told you that -1 represents the student position, which needs which needs a seat, right? Which needs a seat. Who needs a seat? Who needs a seat, right? So this -1 and 0 will be, see, this students need a seat, and where this seat can be, seat can be placed. This 4 at this position 4, he will get a seat, right? So how many position it need to move? It need to move 2 positions. So how will we get the 2 position? The one thing is clear here, that if you want if you want the 2 positions here, this, this minus 1, when we'll add this with 1 by taking absolute value, it will gives us 2. How this is working? Because, and what this 0 represent, this 0 is representing that these many times you need to move to get to the 4, right? These many times you need to move to get to 4. So if you take this summation and add this -1, and after that, you if you take absolute value of this sum, absolute value with this sum, this will become 1. Now when you move to 3, so -1 plus 0 would give you again what? -1. Now we again take the absolute value of this, that will give us 1. And when you add with 1 again, then this will generate to 0. What does it mean? That we have moved from 2 to 4. That's why it is coming 0, that the student 2 gets a position at 4. And now when you add this will become 0. So if you add this part, this will give you 2, right? Why it is working? Because this 0 are representing that you need to move this much of time, you need to move this much of place, right? And -1 is representing that we need a seat, right? We need a seat. So this -1, and when we add this 1 with -1, it generates 0. It means this -1 will be a part of a move, and this 0 representing will be a part of all other moves. So that's why if you see, this 1 is added 2 times, the number of zeros, and this one itself, because after adding this is 1, it becomes 0. That will not be a part of move. So that's why it is working. So again, if you see, at this position 4, it becomes 0. Now what will be the next part? So 5 doesn't need any place, 6 doesn't need any place, right? Okay, there are not equal sheets, right? So this -1 also need any seat. So we will assign this at different position. Let's try to assign this at 10th position, right? So this will be at 1, right? Now this 6 also need a specific position, right? Because this it has a -1. So where it will be get? So in previous we don't have any seats, right? So that's why this sum is not 0 still. If previous position is left, it means it will not be a negative element, not be a 0 element. So minus will need this position. So how many times it will need to move? 4 times, because 6 to 10 is 4. So when you move minus 1, it will give you 1 when we add this minus 1 to here. And when we add this with 0, it will again be minus 1, which will be added as 1. Now again will be 0, again will be 1, again it will be 0, now again it will be 1. Now when we move to 10, this minus 1 will plus as 1, it becomes again 0, and this will be 0. So if you see 1 2 3 4, again we got 4 position. So what is 0 representing? That how many times we need to move. And this minus 1 representing the seats, and 1 is representing 1 minus 1 is representing that the student is needed the seat, and 1 representing that I have a seat, come with me and take that, right? So this is working. So if you cumulative take the cumulative again and again, by doing this you will assign each student a different each seat, right, by taking the minimum of them. This is the motto of the counting shot, right? This is the motto of the counting shot. So again, if you see the same thing with here, again if you see the same thing with here. So basically this is you know now how this is working. This is again, if you see that 2 3 4 5 6, and suppose I have a seat here, and minus 5 want a seat, minus 5 want a seat, right? Minus 5 want a seat, and in between this 0 0 and this will be 1. Minus 5 want a seat, and I have a seat at 2 position, and between them no position is left. So if it has a 1, if it has a 1, it means this 5, how many times it need to move? It need to move 3 times. So when you do this, 1, then again 1, then again 1, taking added, then it becomes 0. It what does it mean? It means it is just a cumulative sum. It is just a cumulative sum. So if you take the difference of all, it will become 1 1 1 0, and this again 0. So if you count this 1 1 1, it becomes 3, right? So what does it represent? It represent that you will just need to take the prefix sum. You will just take a prefix sum. This minus 1, this minus 1 will be added with this minus 1, then again it becomes 0, this becomes 0, again 0, this minus 1, this minus 1, this minus 1, this minus 1, and again 0, right? And after that you will just add all this. You will just add all this, right, by taking absolute value. This minus 1 plus minus 1 is become minus 2, minus 3, minus 4, minus 5, minus 6, and absolute value is 6. So if you see 4 plus 2 is 6, right? Now if you again see here this part, this minus 1 minus 1 minus 2, this will become 0. This is minus 1, this is minus, this is minus 1, this is minus 1, right? This is minus 2. Now again, so this is minus 1 and this is minus 2, and this is become 0. This become minus 1 again, and this becomes 0. Minus 1 and this becomes 0. 0, and this becomes minus 1 again, and this becomes minus 1, minus 1, and this becomes 0, right? This becomes 0. Now if you take the sum of all, if you take the sum of all, what does it will give? 1 2 3 4 5 6 and 7, and that's the answer here, right? So the motto of this minus 1 and doing this like this, the sum and answer, you we just need to, we just need to store all the answers at the positions. And this is just a line sweep problem, which its name is line sweep. The method is similar to this, the method is similar to this, the method is similar to this, right? You will use many times this problem everywhere. So what we need to do, we just assign 0 and minus 1 to all the positions, either it's seats or students, and we will just take a prefix sum from starting to the end position within the same array, and take add and add all the answers after taking that in our answer variable. You can do also that, and you can take like this sum and this answer also, right? That's the same thing. Let's try to implement this. You will understand it better. The first thing is that we need to take the maximum seat in an array, right? So let's just take the maximum, which is equals to 0, and let's just move in this I, and max is max of max seats I. So let's take the cumulative one, uh, seats and the student I. Right, this will give me the maximum seat. Now this should be, we need the maximum, we need the position of the maximum, so we will take mx plus 1 because the maximum should be included, because it is started from 1, right? Now what we will do, we will uh, move to mx, and we will take the cumulative sum. Either you can take cumulative sum, either you can take cumulative sum like this, perfect sum, perfect sum, and add all of them, or you can do like this by taking two variables, like add and then take absolute, add and then take absolute, add and then take absolute. Either you can do both of them. The first thing is that we can either take as 1, so this vi plus vi minus 1. Either I can do this like this, so this will store all the elements like this, 1 0 0 minus 1, so it will become 1 1 1 0 and 0, right? So this will store the number, the summation which is, left in this, it will store the number of moves which required, right? So it can be either negative or positive, so we need to take the absolute value of that. Either it can be positive or negative, so we will only take the absolute value of that, because that will represent the moves, and moves cannot be moves can be count of be positive only, right? So what we will do, we will take an answer and we will just iterate again in this, max value again, and just store the absolute value of vi, right? And just return our answer, right? So let's run this. It is coming wrong. Okay, we haven't assigned uh, implementation wrong. We need to first assign the seats to 1 and the students to minus 1, right? And we haven't done that. So before that we need to just assign at each position seat size to 1, right? It means I need to just do a plus plus, and the students which are placed at some position, we need to assign it minus 1, so I will do a minus 1. So if the seat and the student position is same, it means we don't need to do anything for that, it becomes 0 again. Now this should work, right? This is working, right? So just submit it, and we will optimize it further by taking the sum and answer variable only. So this, there is no need of this two loops. We can simply assign this answer to here. I think you have got understood why I'm doing this, because this vi is already manipulated and we are storing its absolute value by for for uh, counting the moves, right? For counting the moves, right? So we don't need this, we just need to use this, right? So this will be also working if you submit it, right? I will not I should not remove this. I should just uh, okay. So let's copy this and right. So let's just move this to here and let's commit this. Right. This would be more visible to you, right? So we can do this also, right? We can do this. Now one thing is here that we are again we are adding this vi with vi minus 1 and answer is absolute value, right? And the thing is the you can do this by taking this sum also, right? The sum and answer without using this bi. We are doing the same thing with sum. When we add this vi minus 1, instead of that, if you take this sum is 0, and instead of this vi manipulating this vi again, if you take the sum, if you take the sum with vi, you take the sum with vi, and this sum will be this, like this. That's the same thing. This that is the same thing as before. Before we are doing the bi and taking the vi absolute value. Now I'm taking the sum and taking this vi, right? This is the same thing which we are doing. Either you can write like this or like this, both is correct. both is uh, Both is correct, right? Both is correct, right? So both is correct, you can submit it also, no problem is there, right? Either you can like write like this or like this. I will write both of the approach here. It's totally upon your implementation purpose. I have shown you both. Answer plus absolute value of vi. Either you can write like this or like this. The same thing, the same approach is here. Okay. So this is how we will solve this problem. The main problem is the counting shot, which are now the time and the space complexity. Right? Main thing. So one thing is here, you see that we are taking the max value, we are again iterating of n, again iterating of n, and again iterating mx times, right? So for this O of n, right? Again for this mx, O of max times, right? So O of max value, let's take it as m. Now this would be again n, and this would be O of m, which will be again O of n plus m, O of n plus O of. So basically it is O of n plus n, where n is the length of seats for the students, and m is, what is m? M is here the max value. M is max possible position. Right? So this will be the time complexity, and the space complexity would be, so we are taking, so we are taking an extra v for storing, so that will be O of m. So this is the time and space complexity. We have reduced time complexity to O of n plus m, and this is the space complexity. So this is the counting short method. Hope you understand it very well. It's take a lot of effort, but I hope you, if you understand, this will not go in vain. So thank you so much. Bye bye.